Okay, in this video, we'll look at the Do More Designer. This is version 2.7. When it starts up, we see a list of all the projects that we've been working on. So I would like to start with a new offline project. I'll select the simulator and I'll give it a name. I already have a program called Demo1, so I'll overwrite that. Let me maximize that. So on the left side, we have information about the program, about the hardware, detailed information. In the center, I have my ladder logic area. On the right-hand side, I have my tools, my toolbar. Across the bottom, I have some hotkeys. So if I want to enter a open contact, I can press F2. Can also double click. Let me double click here. Default is an open contact. Okay. If I double click on the output side, it defaults to a coil. Okay. So, there are lots of shortcuts. We don't need to remember all the shortcuts. We can always go to the menu on the right-hand side uh, to build our program. So let's start by adding an open contact. You notice the default option is a C. So a C is an internal coil. So let's look at the different types of memory this system has. So we have X's, which are hardwired inputs, Y's are hardwired outputs. We have a WX, which is a numerical value. We have a C, which is a internal coil or a bit. Notice that inputs are bits, outputs are bits, and so are coils. These are just on-off conditions. We also have numerical values. We have double integers, we have unsigned integers, we have real values like 3.7, 2.58, real values. So we have a wide range of numerical values. We also have timers and counters. We have a lot of different options with this software, but let's try to start simple so we can get something to work. So I think for the first one, we'll go ahead and use an X, which is a hardwired input. Let's call it start push button. So for the data type, I would like to type X0. For the output, we're going to go with a Y. So I'm going to call it pilot lamp, and that will be a Y0. And I'm just clicking enter to accept that value. So here I have start push button, pilot lamp. So what I would like to do is accept the changes. I would like to save it as demo1. Then I need to download it to the simulator, to the sim, so it can operate. Right now it can't process this logic. So I'll click on PLC, connect, and it's almost ready. So what I have to do now is download to the controller. And I get an error message. It's more of a warning. It says it's disabled due to incompatibility. This is because we just created this brand new program. So I'll click Write PLC. I'll force a download and say OK. It's downloading. I'll turn the status indicators on. Let me bring my simulator back onto the screen. And I'll click on X0. And you can see how the output turns blue. It tells me that it's working. And you can see here that, of course, it turns green to show that it's also working. Okay. So that's our first quick start video. Before I leave that, let me just caution you, don't close this simulator. Don't shut it down. When you do that, you get error messages because you've lost communications to the controller. So we have to kind of imagine that the simulator screen is a controller, and if I turn it off, I lose communications to it. So if I don't want to see it, I can just minimize it. Let's add a C reference. So we'll do a coil, which can be pilot 2. And notice these are C values, so they're not real connections. They're internal to the processor. Let's accept that. Let's save it. Let's write it. So the accept, save, write is kind of a routine that we get into. So we download it. We bring the simulator back onto the screen. Let's check the operating mode real quick. We're in run mode. You can see the green box down here at the bottom. So it's ready. If I click X, that works. In order to see the C's, what I do is exit the edit mode. If I double click, I can write an on condition. So you see that works as well. So let's bring the simulator back. That works. If I double click and turn that off, that works as well. So we have our first operational program. It's got a real input, a real output, and 2 internal references. So let's stop this and we'll make another one.